Hello, friends. So can you do this integral? Root 1 minus another root 1 minus x squared and then dx. Again, it may not be obvious where to begin, but we do see a clue, which is we have 1 minus x squared and we have x, although this x is all the way on the outside of the roots here. So we can begin by setting u equal to 1 minus x squared. That's pretty good because that then tells us that du is negative 2x dx, which then tells us that negative du over 2 is equal to x dx. That's pretty good. Because now this red x and the dx over here can be replaced with negative du over 2, and this expression can be replaced with u. So that's going to give us the next stage. So x dx is going to become negative du over 2. All right, and then here we will have the root of 1 minus the root of u, essentially. Okay, now remember this is like negative 1, so negative 1/2 that is, so you can write this as negative 1/2 on the outside, and what's left on the inside is the root of 1 minus the root of u with du. From here, again, not really obvious how to proceed, but you just keep trying a substitution. So let's set p equal to the root of u, then this implies that dp is 1 over 2 square root u, just differentiate that, with du. All right, so that implies that 2 root u dp is equal to du. But remember that the root of u is equal to p. So it's 2p dp equals du. So now we come back, we continue over here. Negative 1/2, antiderivative. And remember we're replacing the p here with the root of u. So we'll have 1 minus the root of u becomes p, and du becomes 2p dp. It's taking us somewhere. Let's continue. So now I can factor this 2 out, divide it with the 2, leave the negative for now. So it's going to be negative antiderivative of 1 minus p and then p dp. So what do you do now? You got to try another substitution. Let's say I'm going to set v equal to 1 minus p. Well, this is going to first of all imply, for example, that dv is equal to negative dp, which, for example, means that negative dv equals to dp positive, right? You just divide by negative 1. Now, this further also implies, since we have, notice here, p, in this position, there's a p, okay? So we have to solve for p to be able to replace it. So I can say something like p equals to 1 minus v from v equals 1 minus p. So now that's going to give us here antiderivative, so negative. Now, under the root symbol, we have, let's see, 1 minus p is v, and then p is 1 minus v, and then dp is negative dv over here. Do you see that? So it's going to be negative dv. It's going to become antiderivative of, let's see, v to the 1/2, basically. Distribute this, raised to the 1/2, minus v raised to the, so this is now like the root, right? 1/2 plus the 1, that's going to give us 3/2 dv. Now, this we can do by the power rule. So we're going to continue down here. We'll have v to the 1/2 plus 1 here over 1/2 plus 1 minus v to the 3/2 plus 1 over 3/2 plus 1 plus, let's say, c. Now let's clean this up a little bit. So it's going to be a half plus a 1. But then you got to flip it by keep change flip. So it's going to be here 2/3 of v to the 3/2 minus, same thing on the bottom, right? So we write the 1 as 2 over 2, so 2 and 3 is going to give you a 5/2, but then you got to flip it, so it becomes 2/5, and then v raised to 5/2 plus c, basically. Now we may start making replacements. How many replacements do we have to make, though? So first of all, recall, I'm going to have to write all the way over here. V was equal to 1 minus p. So first we will have 2/3 of 1 minus p to the 3/2 minus 2/5 of 1 minus p to the 5/2 plus c. But now remember that p, somewhere over here, p up here, so right here, look, was equal to the root of u, correct? So that means we're going to have now 2/3, 2/3 of 1 minus the root of u to the 3/2 minus 2/5, 1 minus the root of u to the 5/2 plus c. Get rid of that. But now remember that u is equal to 1 minus x squared from the very top. So that's going to give us 2/3, and then 1 minus the root of 1 minus x squared raised to the 3/2 minus 2/5, and then 1 minus the root of 1 minus x squared raised to the 5 halves plus c. Let's make sure this is the right answer. So 2/3 1 minus root of 1 minus x squared to the 3 halves minus 2/5. Correct. 1 minus root of 1 minus x squared to the 5 halves plus c. This can be written, right? There's a product form. The answer in that form is for you to try to figure out. So can you write like this part, for example, as a product? It can be written as a product as long as you work on it. All right, let me just zoom out a tiny bit in case you're curious about all the work from top to bottom. It's good to do that every now and then to see the whole process. If I can get this to move down, there you go. Leave a like if it's helpful, and please remember to subscribe.